Hello and welcome back, my pre-calculates. You know, the good news is that even though this is like the McRib sandwich, backed by popular demand, this is the second to last section of trigonometry. Yay! There was much rejoicing. So we're going to be talking about double and half angle identities today, and our objective is to be able to use these identities to find function values, the actual values, the exact values of trig ratios, and to also simplify trig expressions where you kind of plug in and substitute and get things to shake down and simplify. So let's get going. The first example, it says find the sine of 2 theta, cosine 2 theta, tangent of 2 theta. Notice you've got 2 times theta. That's the double angle identity because you're multiplying 2 times your angle. And they also want you to know the quadrant in which 2 theta lies. Now, I don't have pre-printed notes for this section. There should be enough room on page 7 or 8, the bottom of those of your note packet, in order to copy these down. So you'll just have to copy them down. You'll have to pause where you need to pause. The first step is to draw the angle and label the reference triangle. So if I draw my axes, my angle is in the first quadrant. So theta is in the first quadrant. So here's the terminal side of my angle. And it says the sine is 5 over 13. If you remember, sine is y over r. You could also think of it as opposite over hypotenuse. I drop down my perpendicular to make my right triangle. So this right over here is going to be where the 5 goes, and then this would be the hypotenuse, or r, if you will. And so we've got that. Now, the only other thing I need is I need this missing side. How in the world can we do that? Well, you remember Pythagoras, who's that square on the hypotenuse. You're going to use the Pythagorean theorem to find this missing side. So if you do that, you'll have 5 squared plus b squared equals 13 squared. And when you solve it out, you'll get b equals 12, because you'll have 169 minus 25, take the square root, and so on. I'm skipping that because I know you guys can follow. Then, step 3 is going to be to apply the double angle formula. So my double angle formula was sine of 2 theta equals 2 times the sine of theta cosine of theta. Now that I have all 3 sides of my triangles, I can easily form the sine of theta, which was given 5 over 13, and the cosine of theta. Cosine is x over r, which would be 12 over 13. So I just plug that in place. So it's going to be 2 times 5 over 13 times 12 over 13. This was the sine of theta. This was the cosine of theta. Then I multiply straight across. I end up with 120 over 169. Yes, I know it's a fraction. Fractions need love too. It's also got big numbers. Big numbers need love too. So next we're going to find the cosine of 2 theta. You have 3 choices for the cosine of 2 theta. I tend to like this one, cosine squared minus sine squared, but you can pick any one you want. The reason I like this one, though, is because you'll have fractions with the same denominator, so they're easier to simplify. So you got 12 over 13 squared minus 5 over 13 squared. That's 144 over 169. And 25 over 169. Again, the reason I use that formula, see how you ended up with the same denominator, so you can subtract the numerators, bada boom, bada bing, you got it. 119 over 169 would be my cosine. Lastly, we're going to find tangent. Now, here is the tangent formula. I never use this. I'm just telling you, I'm showing you the official way, but I'm going to show you a shortcut in just a second that you will go, oh, that's so wonderful. So if I do the tangent of theta, it's going to be opposite over adjacent, which is 5 over 12. So if I put that in place here, it'll be 2 times 5 twelfths, 1 minus 5 over 12 quantity squared. When you simplify that, you get 10 twelfths. Or you could have done 5/6, either one. 1 minus 25 over 144. Then when you simplify that, you have to change that 1 to have the same denominator. So you'd have 10 over 12 divided by 144 over 144 minus 25 over 144 minus 25 over 144 equals, so when we simplify that, we get 10 over 12 divided by 119 over 144. And when you're dividing by a fraction, it's the same as multiplying by your reciprocal. So we will flip the second guy and multiply. So we'll flip this guy over and multiply straight across. When you do that, it'll reduce down to 120 over 119. Do those numbers look familiar to you? Sure, look at this. This is 120 over 169, 119 over 69, 120 over 119. So here's my shortcut. Tangent is the same as sine over cosine. If you just take these two and divide them, they should probably have the same denominator every time as well, because it's, over the hypotenuse for both of them. So my shortcut, to find 2 tangent theta, use what you get for sine 2 theta and divide it by what you get for cosine 2 theta. To me, that is easier than all of this. But wasn't it fun to review all that fraction stuff? Now, another thing they ask us to do is find the quadrant in which 2 theta lies. So the quadrant is determined by the signs of the trig ratio. So when I look here, everything's positive in this first quadrant. Only sine is positive in the second quadrant. Only tangent is positive in the third quadrant. And cosine is positive in the fourth quadrant. Since all 3 of these values that we got are positive, that means our 2 theta is going to lie in quadrant 1. All right. Well, we're going to continue on and do a few examples like you're going to see in your classwork. Now, first example, you're evaluating a trigonometric expression, and it says here to use theorems 18, 3, and 4. What that means is they want you to use the half angle identities. When I look at this cosine of 165, we have done this problem before, but we did the sum identities where you did 30 plus 135. But I want you to use the double angle formulas and the half angle formulas. So you have to say, well, if I take this times 2, what would that be? Would that be a special angle? Well, in this case, 2 times 165 is 330. Well, half of 330 is 165. I know this is kind of a convoluted way to go around it, but when we double this, we get 330. So I know 330 is a special angle. So I'm going to use my half angle formula, because half of 330 is 165. So that's kind of, you're going backwards. Doubling and halving, they're inverses of each other. So let's see how this plays out. If I apply my formula, my half angle formula, I'll have the opposite of the square root of 1 plus cosine 330 divided by 2. And cosine of 330 is a special one. We have it on our chart. It's square root of 3 over 2. So if we have this, oh, it looks so nice. You have a square root, and underneath the square root, we have another square root, and we have fractions. We need to simplify this guy a little bit. So what I'm going to do is get rid of my fraction within a fraction by multiplying the top and the bottom by 2. If I do that, I'll have 2 times 1, which is 2. Fractions will cancel out, and I'll have 4 in the bottom. So I end up with 2 plus square root of 3 all divided by 4. And I know the square root of 4 is 2. So my final answer is going to be this guy. Square root of 2 plus square root of 3 over 2. Double square roots. Woohoo! Who knew? Tangent of pi over 12. Well, half of what would give me pi over 12? That's half of 6. Half of pi over 6. So to do my half angle formulas, I'd have a half times pi over 6. I'd rewrite it like this so I know that pi over 6 is the angle measure that I'm putting in there. If you wish, you can convert these to degree if it makes the math a little bit easier for you. So I would have, if I do my tangent half angle formula, tangent of half theta is 1 minus cosine of that angle over the sine of that angle. So we're going to end up with 1 minus square root of 3 over 2 divided by a half. Here again, we have fractions within a fraction. So I'm going to multiply top and bottom by 2, and that'll eliminate my fractions in my numerator and my denominator. 2 times 1 is 2. 2 times square root of 3 over 2 means the 2's will cancel, and the 2's will cancel there. So I'd end up with 2 minus square root of 3, because the denominator becomes 1 and anything over 1 is itself. So that should give you help on the second section of the homework, which are numbers 7 through 15. They're going to be just like that. Last part of your homework is going to look like this. It says just to simplify, and this is where you start making some substitutions for the trig identities. And I have 2 strategies for you. Strategy 1 is to try to match which formula looks like the expression. So for example, in this one, 2 times sine of something, cosine of something. Does that look like anything? This is the formula. Sine 2 theta equals sine 2 theta, cosine 2 theta. See how those look similar? The right-hand side matches this side. So what we're going to do, we see that our theta in this case is the x over 2. X over 2 and x over 2. So we're going to replace this whole side, this whole thing, with sine of 2 times that angle theta. So we're going to have sine of 2 times x over 2. That's where that comes from. 2 times x over 2 is just x. So we're going to end up with just sine of x. And that's it. That's simplified. The second type is like this. We try to match the which formula looks like the expression. That's our first try. If that doesn't work, no formulas match, expand out the expression. So here we have sine of x minus cosine of x quantity squared plus sine 2x. There's nothing, no formula looks like that. So we're going to have to expand out and see if we can simplify it down. If I take sine minus cosine and I square it, that's going to be sine squared minus 2 times sine cosine plus cosine squared. And then this sine of 2x becomes 2 sine x cos x. So you have expanded out the expression, and let's see if anything cancels. Well, right away we see the minus 2 sine cosine cancels with the plus 2 cosine cosine. So we end up with sine x squared, or sine squared x, and cosine squared x. Sine squared plus cosine squared is the same as, oh yes, you guessed it, 1. So my answer is 1. Pretty cool, huh? Alright, so hopefully you've seen how to use the half angle formulas today and the double angle formulas to find some exact trig ratios, and also given you a couple of strategies for simplifying trig expressions. We will see you later.